For the next presentation, I give you a brief overview. So what we will talk about in next 30 minutes. Last year, we introduced the concept of the new product, ENCY Hyper. At that time, it was just a vision, a bold idea. Today, we are proud to present ENCY Hyper as a commercial product. Over the past year, the team has worked intensively to bring the vision into the real life. And those who have once attended the last conference, I just remind you that ENCY Hyper is a revolutionary product that unites online and offline robot programming in a seamless experience. We believe this hybrid approach will transform development workflow and unlocks a new level of collaboration and productivity. And this is not just a new product, it's a strategic decision. We have high expectations for the business growth and breakthrough potential it represents. And now, to tell you more about the journey, the progress made over the year, and powerful new capabilities of ENCY Hyper offers, please welcome to the stage the person who led this transformation, Ilnar Galiullin.
Thank you. In the world of industrial robots, we have two different ways of programming. We can use online programming using real robot or offline robot programming using digital twins. And each way, each approach has its own benefits, each way has its own power, but at the same time, each way has its own weak points. Let's explore them. In online robot programming, customer can use pin-down panel to control the robot. Customer can move joints. Customer can teach points one by one. And even if something goes wrong, customer can just select wrong point and teach it again. It feels very, very natural. It's clear to customer and easy. As a rule, everything is already pre-installed to machine pin-down panel, so it's no need to buy any software. It's no need to configure anything. Of course, online robot programming has a lot of problems, a lot of weak points, and first of all, it's just impossible to build any complex toolpaths. Just imagine teaching thousands of points for milling with simple part. It's just not acceptable in real work. Moreover, the quality of created program depends on programmer skills, depends on experience of engineer, and there is no simulation available, no toolpath preview. So if something goes wrong, it will go wrong in real hardware and can damage it. In offline robot programming, on the other hand, we can use ENCY CAM system for build a very complex toolpath just in few clicks. Customer will receive optimized toolpath and collision-free movements. And for sure, customer can simulate everything before running on real hardware. Offline robot programming looks much better than online robot programming for complex tasks, and it's our way to control robots using ENCY. But today, more and more, we see also weak points of offline robot programming. First of all, it's quite hard to debug programs in real robots. Yes, we can make a very complex toolpath in few clicks. It can take just a few minutes. But afterward, we need to copy this program to USB stick. We need to go to the real robot. We need to upload this program, and we can finally start debugging. And if something goes wrong, if we see very small mistake, even in this case, we need to go back to our office, run ENCY, fix project, make second version of program, and we can spend all day walking between the real robot and ENCY. In this case, we stop working as an engineers and we start working as a delivery guys. We just deliver program to the robot. It's just not optimal. And second problem is digital twins. As a machine maker developer, I can tell you for sure that your digital twins will never be a perfect copy of real objects. Your real robot will always have some rotation angle, your rotary table, your positioner, your rail. will never be perfectly aligned, and your gripper, your spindle, will be always mounted a little bit off. And even if you make a lot of measurements, even if you make a lot of calibrations, even in this case, there will always be some small cable or tube which is not present in your digital twin, and your real robot can damage this cable. And finally, some kind of tasks just too simple to handle with full power of CAM system. For example, if your customer needs just to pick this part and put it inside the CNC machine, it's quite hard to explain him what he's really need a full CAM system, because customer need to learn CAM system, customer need to create project, make a digital twin, make a post-processor, use it, and upload programs each time to a real robot. Sometimes using full power of CAM system, it feels like overkill, it's too complicated. So, we have two very different ways to program robots, and each way brings its own power. But why to choose only one way? What if we will take benefits from each way, combine it together into one application, and install to industrial PC directly connected to robot? And we made it, and we called it hybrid programming. We called it ENCY Hyper. ENCY Hyper is our new solution for programming robots. ENCY Hyper can be installed to industrial PC or tablet directly connected to the robot. So ENCY Hyper can control a robot in real time. ENCY Hyper provides very simple and clear user experience and user interface, but at the same time, ENCY Hyper brings you full power of ENCY CAM system. Let me explain the difference between ENCY Hyper and ENCY Robot. ENCY Robot as an ENCY, it's a full powerful CAM system. It's installed to office PC, and ENCY user, as a rule, it's a very qualified engineer with strong CAM experience. ENCY Hyper, on the other hand, is installed to industrial PC, and ENCY Hyper's user don't need to have any CAM experience at all, because this program is quite simple and it's perfect for touch interface, for standing real close to a real robot and modifying your programs. ENCY Hyper can work as a standalone solution, in solo mode, and ENCY Hyper can work in joint with ENCY CAM system. Let me show you a few projects created in ENCY Hyper as a standalone system. First of all, of course, it's a traditional application. It's pick and place. Here, robot will pick with objects and put to a table. Of course, you can use ENCY for creating pick and place operations. You can use even embedded software, like online robot programming. But unlike the traditional approach, here we don't need to teach all these points manually. We can use only two blocks, pick and place. So we just show our robot what to pick and where to place. Very simple and very clear to customer. Next task is palletizing. Palletizing is a good example of area where using full power of CAM system feels like overkill, it's too complicated, but using embedded software can provide flexibility. Even if you teach all these points manually in online programming, in embedded software, if you need to change pattern, stacking pattern, or you need to change box dimensions, in this case, you need to make program from the beginning. But in ENCY Hyper, you can change patterns, you can change box dimensions, you can change workflow just in few taps using only your finger, and it will take just a seconds. Next good approach of using ENCY Hyper as a standalone application is packing. Just see how easily our robot, controlled by ENCY Hyper, can pick this box and then start stacking with phones inside this box. We can change number of phones, we can change position, we can change pattern, we can change everything, and ENCY Hyper can be used not only for moving phones, but ENCY Hyper can move any objects in one project. And last one. And now, box is ready to be delivered to your customers. And finally, ENCY Hyper as a standalone application is very good for handling assembling tasks. in this project, robot assemble with engine. But actually, I would like to show you this project to prove what ENCY Hyper can control not only robot, but also any count of additional axes. ENCY Hyper can control rotary tables, rails, grippers, vacuum system, anything, tool changers, everything can be controlled by ENCY Hyper. And now just imagine the power of ENCY Hyper if we give it power of ENCY CAM system run in background. Thanks to our ENCY Clouds ecosystem and thanks to our ENCY API, we can run ENCY in background and we can use ENCY power in ENCY Hyper. Let's imagine I need to machine this part. I need to grind side face and end face. Of course, I will use ENCY CAM system because ENCY CAM system is obviously best CAM system in the world. I will use 5D surfacing operation. It's quite simple. I just can select curve and select surface to be machined. And what's it? Simulation looks good. And I will create one more operation for same surface, but now using weaving. I will speed up a video a little bit. And two more operations for machine end face. Simple and using weaving. Okay. Here in ENCY, I have 4 operations, 2 operations for side face, 2 operations for end face. And in ENCY, I am focused only on my part, I am focused on my tool and tool path. I don't think about part position, I don't think about parts count, I don't think about links between operations, I don't think about approach and retract. ENCY is very good for building optimal tool path. After that, I can go to the real robot and start using ENCY Hyper standing close to the real robot. Here I can see what I will need more table, so I can just add this table directly in Hyper using only my finger. It's not necessary to run ENCY, it's not necessary to run Machine Maker. I can do anything standing really close to the real table, so I can measure the distance and I can set this distance here. I can add some parts, I can add part spacing, I can move part holder, and for sure I can move the table and I can move this table relative to the robot frame, so I can use calibration data. And that's it. Now I can put some parts to the table. I can import 3D models. I can create parametric parts like cylinders or cubes, because for some kind of task it's not really necessary to show full 3D model. I will put one part to an out table and finally can go to the programming section. Here I can import toolpath created in ENCY just in one tab. Okay, toolpath is ready, but for now my robot even doesn't have a part. So I will ask robot to take part from the table, then make 2 operations for side face milling, side face grinding, then put the part to a second table. After that, robot must pick next part from that table and finish machining by grinding end faces. And finally, place machine part to the first table. That's it. Now my robot can do real work. My robot can grind one part. Put it to a table, pick next one, and do end face machining. And using weaving. But what if I need to machine all parts, not only one? It's very simple. I just tell my robot what if there are any unprocessed part to the table, on the table, robot must pick next one and jump to the first block. So now robot can machine all the parts. After I checked everything in simulation, After I see that there is no collision, everything works good, I can connect to the real robot using only one tap on this live button and start playing with program on real robot. ENCY Hyper controls robot in real time, so if anything goes wrong, if robot goes crazy for some reason, ENCY Hyper will detect it and immediately stop the robot. So ENCY Hyper provides you high level of security. Now robot picks the part, move it to the grinding tool, and start machining. And now Hyper start playing toolpath received from ENCY CAM system. This toolpath may be any complex. It's no problem for ENCY Hyper to handle very big programs with thousands of points. Actually, ENCY Hyper sends tasks one by one, points one by one, control robot in real time, so it's no problem to send really big programs. First operation is complete. Now, second operation also sideways, but using weaving. I will speed up a video. When robot will put this part to the table, take next part and process end faces, and finally put process part to the first table. So in ENCY CAM system, we can be focused only on toolpath, we can think on part, we can think on obtaining the best surface and optimal toolpath. In ENCY Hyper, we can modify part counts, we can modify part position, we can add any count of additional movements, we can add input-output control like opening CNC doors. It's all of these tasks can be done standing really close to the real robot, and we can debug in real robot. So ENCY Hyper provides you with very good level of flexibility. ENCY Hyper comes with a lot of amazing features. Just let me point out you the most impressive one. First of all, ENCY Hyper comes with embedded collision detection and collision avoidance. So if something is wrong, if there are any collision, your customer will see it in simulation. And moreover, customer don't need even to avoid these collisions manually, because ENCY Hyper can move from one position to another, avoiding any collisions. Just look how easy our robot can move from one position to another, avoiding any collision with obstacles. And all these toolpaths have been done automatically. Thank you. Next feature I would like to talk to you about calibration. Let's imagine what we have a table and we have some parts. The distance between parts is 100 millimeters and the mounting angle is straight, it's 90 degrees. But of course it's only on theory, because in real life the numbers will be a little bit different, the distance between parts will be a little bit more, and mounting angle will not be so straight. And for your customer, in customer's mind, it's not so big deal because number is not too big and everything should be fine, even for pick and place tasks. But actually, with small offsets will be a big problem at the last part. With offsets is not too big on the beginning, but at the last part, your robot will not be able even to pick this part, because real position of part will be not the same as we planned. Robot will go to the wrong position. And at this point, usually you and we start very hard conversation with customer. We talk about frames, we talk about the TCP calibration, we talk about base calibration, we talk about frames and maths. But customer don't want to work with frames. Customer want to work with parts. And this is a big problem to explain customer what calibration is really important. And in ENCY Hyper, we can make a calibration in the very easy way. Instead of talking about frames, we can just ask customer to show the real position parts. So if robot tries to pick the part and customer see what real position of part doesn't match to the digital twin, customer can just stop the process and show a robot real position of part, and Hyper will update digital twin automatically. Instead of talking about frames, instead of making calibration, just show where is your part really located. And same for the second part. When customer calibrates second part, when customer fix position of second part, ENCY Hyper will keep position of already calibrated parts at their places. So the process will be very clear to customer, and you don't need to talk to customers about the math anymore. Very simple. Now let's talk about the AI a little bit. ENCY Hyper comes with embedded AI system. ENCY Hyper can detect your parts. ENCY Hyper can detect part types. ENCY Hyper can detect part position. All what you need is one cheap camera. You don't need very expensive hardware. You can buy literally $10 camera from the local shop. Connect it to Hyper using USB, and that's all. After that, ENCY Hyper will be able to see your parts. ENCY Hyper will be able to detect part types and part positions. Just imagine what your customer don't even need to define part positions manually. Customer can just put parts to a table. ENCY Hyper will check with parts, detect part types, and detect part positions. And when ENCY Hyper will update parts position on digital twin and can start program automatically. So your customer needs just to put parts, make 2 steps back, and robot will do all work. And this is not expensive solution. You can do it using one chip camera because ENCY comes with very powerful AI system embedded. And with AI recognition works locally on the Hyper. We don't need to send anything to our servers. Everything will work only on Hyper. The huge advantage of using ENCY Hyper is the fact that you can use one system, one UX for controlling very different robots. ENCY Hyper comes with pre-installed, modified, verified drivers for KUKA robots, FANUC robots, and robots. We built our drivers without requirement of enabling expensive options like a FANUC PCDK or KUKA options. For KUKA, we use C3 bridge. For FANUC, we use FANUC interface. And Robot hopefully have an open API. So you don't need to buy any expensive extensions to your robot. Hyper can control very basic configuration of your robot. Of course, we will work on adding our brands also. Usually it takes about few weeks, maybe few months to add new robot manufacturer to Hyper, because we need to find real robot. We need to go and make some tests, and only after that we can write some drivers. But if you have a robot in your office, actually you can write your driver by yourself. It's not impossible task because ENCY Hyper keeps all logic inside, and robot driver is necessary to do just the basic things like a moving robot, like a reading robot position and handling inputs and outputs. And as a proof, I can show you amazing success, amazing result of our partners CNC Solutions. We made this driver for Style robots, and it take I think few weeks only, and this can prove what you can do, build a robot driver by yourself. And you have another option. You can use the hardware solution from our partners, Fuzzy Logic Technologies. You can use this hardware. It's a PC. So if you have Staubli, ABB, Yaskawa, or Universal Robot, you can connect this robot to this PC, and then connect this RTOS to ENCY Hyper, and right after that, ENCY Hyper will be able to control also ABB, Yaskawa, Universal, and Staubli robots in real time. It's very good hardware. I recommend you to take an attention to this hardware. ENCY Hyper is ready to be released. You can download it. You can try it by yourself. You can connect it to your real robots. You can try it in simulation. And please share your feedback. Thank you.